Hey guys, this is Troy Novak. This is for a security course, computer security course at Metro State University. It's ICS382 and my instructor is Dr. Fitzgerald. I'm going to be showing you a demonstration just on how to use like a very simple hash table to try to crack a password. I'm not going to do anything more intense than that. This is strictly for educational purposes. And yeah, if you couldn't guess by my little introduction, I'm going to be talking about password cracking and some popular techniques that people are using these days. So there's two types of cracking. There's online guessing. This is you're actually online and on your target system and you're just guessing. It's kind of like a brute force technique. A lot of places these days, a lot of systems are using like lockout mechanisms. It's a part of their security policy, so you can only try a certain amount of times before you get locked out. That's a really good defense to this because you can only try a certain amount of times. Unless you have a really good idea of what your target's password is, you're probably not going to get it, and you're going to get locked out, and they're going to get notified, and there's an automatic fail. The second type is offline guessing. This is where the cracker's trying to get the file that the secret's hidden, the secret. In a lot of cases, it's a hash. There's a lot of different types of hashes. Probably not gonna have time to go over that, but yeah, this is most of the time what we're talking about for password cracking, because unless the system's security is implemented in a way that they can detect that you're doing things, or if they go back and detect an anomaly, then you pretty much have all the time and whatever resources you have at hand to crack the target's password. So, I'm only going to really be talking about these top three here. Basic brute force technique, a dictionary attack, and a rainbow table attack. There's other different kinds of cracking strategies too, like phishing. You know, you get an email, they're telling you that there's something wrong with an account and they want you to enter your information just to make sure. There's malware, stuff like keyloggers, where they're trying to figure out what you're typing into your computer and try to take an educated guess at what your passwords might be. And then there's shoulder surfing. It's really laissez-faire. Just you got kind of an idiot coworker who's trying to sniff out your password by just peeking over your shoulder, you know, that kind of stuff. So first, just a basic brute force technique. It's pretty much just trying to calculate every possible combination of characters and then trying them all and testing all of those different hashes versus the target password's hash. Excuse me, relies mostly on just the raw computing power of whatever system you're using to crack the password. It's really not very clever. There's a lot of programs out there that you can just download for free off the internet, and they will do this. So it's really, like, you don't have to be a very strict hacker in order to just use like a basic brute force attempt. The complexity of the password isn't a huge deal because it's just going character by character. It mostly depends on the length. Length is what's going to designate how much time it's going to take, because as you add characters to a password, the possibilities grow exponentially for the different kinds of combinations that there can be. They're really straightforward, and it just depends on how much time and how much processing power you have to crack. That's why, like, GPUs, they're huge. Just recently they spiked in price because of cryptocurrency, but I mean, you thread together a bunch of GPUs and you have an insane amount of processing power because they're built for just mathematical functions and calculating these kinds of things. So GPU systems are really popular among crackers. This is kind of an outdated table. I think it's from 2012, so processing power has definitely increased substantially since then, but it still gets the point across for what I'm trying to use it for. So this is the number of characters in your password, and this is the complexity of your password. So this first one's numbers only. This first one's upper or lowercase letters, so either all upper or all lowercase. This one's upper or lowercase letters mixed, so you can have both upper and lowercase letters in your password. This one's the same thing as the last, except throw numbers in there, and this one's the same thing as the last, except throw special characters in there. So we'll start with 8 because today that is like one of the main implementations in password policy. Is it's got to be at least 8 characters. I think they might be moving up to 10 soon, just because of the processing powers. It's getting so much faster. But so you go numbers only, like that. You pretty much have it. Throw either uppercase or lowercase letters, because numbers you only have 10, with 0 through 9, and upper lowercase letters you have 26 possibilities, like options for characters, and that jumps up to 13 minutes. Then you go upper or lowercase, so you can have either or mixed in there, and now you've got 52 different kinds of like choices for characters, and that jumps up to 3 hours. And you throw numbers in there with the upper or lowercase letters, and it jumps up to 10 days, and you're adding 10, so you have 62 options for each character. And then you throw special characters in there like symbols, and that jumps up to 57 days. And I have no idea how many special characters there are, so I can't do the math on how many actual choices there are for each character. But so that's, yeah, 57 days. And again, this is back in 2012, so that might be cut down a little bit. But let's go like 12. So numbers only with 12 characters. You can look at that like 8, and you just add 4 more characters, and it jumps from instantly to taking at least an hour. And then you jump over to just upper or lowercase letters, and you've got 12 years that it's going to take you potentially to crack that password. And then you jump over upper or lowercase mixed, you got 600 years. And then you jump over here to numbers in there, 108,000 years. And then add a special character in there, and you're at 5 million years. And that is insane. I mean, you come down here to 18, and nobody's gonna have an 18-letter password, you know, or character password. I would have to write it down, and that kind of defeats the whole purpose of the security. If you have to write it down, if you have a password saved in a non-encrypted file, then it's just, what's the point of having a password? But you go to 18 characters, and just right off the bat, you could just use numbers, and it's 126 years. But then you jump over here to the most complex, and what on my key, it's quintillion. 1 quintillion years is what it would take. And that's, I mean, you even think about how much our processing power has increased in the last, this is 2012, so 6 years. I mean, it might have dropped, but not substantially enough to make it. It's still going to be at least, what, you figure 1,000 years. I don't know that for sure, but I'm just assuming. You can't cut 1 quintillion down very much. So yeah, it's just insane. I mean, the like numbers, upper, lowercase, symbols, that's a necessity in any password. The next kind of attack we have is a dictionary attack. So it's a type of brute force attack, but it takes advantage of like common words. So you're building a list, a text file or something of just common words to kind of filter through. And it's even better if you know certain things about the target already, like maybe their birth date or their spouse's maiden name, or like a middle name of a child or something like that. Something kind of very like personal to them that they might be using as a password because they don't think many people know it. If you get your hands on that, throw it into your dictionary, that's going to make it even better because a lot of people use that kind of stuff. It's faster than just a basic brute force attack, but if you create a password and you don't use common words, or just words at all, just make it characters, maybe something like not even initials. I mean, somebody could figure that out too, but just something maybe like a phrase that you can think of, and then just use all the first letters or all the last letters, and then throw your numbers, uppercase, lowercase, special characters in there. It's pretty easily thwarted if you're good about your passwords. It's just hard to remember those kinds of passwords. A lot of us use simple passwords because they're easy to remember. And the last kind of attack I'm going to talk about is a rainbow table. So a rainbow table pre-generates a table of hashes, and then it just does a table search through that, and then compares all those different hashes that you pre-generated against the password's hash to try to find a match. It's a lot faster than both a basic brute force and a dictionary attack. The only thing is, it takes up a lot of memory. I have here just an 8-character long lowercase alphabetical string, so all lowercase, no numbers, no special characters, hashed using MD5 protocol. Would require a table that would take about 4 terabytes of space. So these days what crackers are doing is they're taking the first character and the last character, and they're hashing those, and then they're just trying to find a match between those two hashes against the passwords, and then they just kind of fill in the rest. I've looked at a couple algorithms. It's a lot of math. I'm not entirely sure how they work, so I can't really go into too much detail about how that works, but it does significantly cut down the amount of space needed to generate a rainbow table. Let's see. Okay, this is a good time. I'm going to go do my demonstration now. So I found this website. I'm using software called John the Ripper. You can do brute force attacks, rainbow tables, dictionary attacks, but I'm pretty much just gonna use this website. It's gonna generate. I'm gonna type in a username and a password. So I will do just my name for username and password. I'm gonna go 5 characters because I don't want it to take forever. And then what it's gonna do, I'll hit create here, and it is going to generate an encrypted hash. So right here, using MD5. This is not the password. This is the username for the password. And so I'm going to copy this. This is the hash. And then I'm going to go to my directory. So this is the folder for the John the Ripper. And right here I've created a text file, just hash text files, so I can save my hash. So we'll open that up. And we'll paste this in. We will save. I'll close out of that, and then it doesn't actually have a user interface, so other than the command line, I'm going to open up my command line, and then I have to change the directory. So let's go C, and then we will go. I believe this is what my folder's name is. Nice, and then we will change to. All right. So first, I'm just going to run the executable for. So these are all the command line prompts that you can use that John the Ripper gives you. I haven't really dabbled with too many of them. I've just been using the basic one that it's basically just to make sure that it's working, but it kind of gets the point across that it's just like a very simple hash table. It's just I only have one hash in my table, and it already knows what it's looking for. Because it's encrypted using right here MD5. So these are all the hashes that it's hash protocols that it's going through, and it's trying to find one. So it's using MD5. It's going to decrypt this hash, and it's basically going to have the password, the dummy password that I created on the website. So we will run hash txt, and it might take a little bit here. So what we're going to do is I'm going to go back to PowerPoint. This might pop up at some point, so I apologize for that. We're going to go back. We're going to finish up. Oops, not from the beginning. Let's go current slide. All right, we left off at the study. All right, so this group of people, these guys did a study earlier this year, and they published it in May. And so what they did was they collected a bunch of old passwords that were created between 1980 and 2003 from a university, and these passwords were used, I'm assuming, by faculty to access the school's online grading system. So what they were doing was they were kind of testing. It was kind of like a social engineering thing, I guess, if you want. They're kind of seeing like how complicated people were actually making their passwords, and what the university did was they created a password for you first. There was like a default password, and they told you what it was, and you go in and change it. So they collected over 185,000 passwords, and only about 150,000 of them were unique, which means that about almost like 35 to 40,000 passwords were used by multiple people, which I don't think they would give you a default password that's the same as somebody else, because I'm pretty sure what they said in the study was that your password, your default password, was the first initial of your first name and the first initial of your last name, followed by a 4-number string. So it was only 6 characters. And I mean, maybe you'd get the same as somebody else, but I'm assuming that there were people that made the same password as other people and changed it to that. And I got a table here. So this is the sequence that they did the actual attacks. So first 6 of them were just basic brute force attacks. Then they kind of jumped on. They did a combinator, so like a dictionary attack with 2 dictionaries, and they combined them. Even though it's the same dictionary, it's multiple words. So if people were using phrases, and then they did a dictionary attack after that. So just in this first one, so this is the old pattern I was talking about. So they've got 2 lowercase letters, which is first initial, first name, or first letter, first name, first letter, last name, followed by the 4 digits. They got 115,000, almost 115,500 of the 150,000 passwords just in that, and it only took them 20 seconds. And to me, that's pretty ridiculous, because that means that many people either didn't change their default password or changed the default password but made it similar to the default password. So then you go down, it incremented it to length to 6, whatever. What was the longest one? I think the longest one was this 20-hour one. So yeah, so a length of 10 lowercase English alphabet characters, and then digits as well, so 0 through 9. It took about 20 hours, and they only got 222 of them. I'm not sure if they did this and they like took away the passwords after they got them, or if they just went through the whole thing every time. They didn't really touch on that at all. I think it was just they were just trying to use as many attacks as they could to try to get as many of the passwords as they could. So I'm pretty sure this is like they took them out and then they would attack what was left. But then you look at this. So 20 hours and they got 22. That's against a 10 length of 10. Just a strict basic brute force attack. Then you go on to the dictionary attack, and in 1 second, using a 675,000 word dictionary, in 1 second they got 248. And that's kind of crazy. Excuse me, kind of crazy. Just how quickly that worked. I mean, it was 20 hours and they got 222, and 1 second they got 248. So just the efficiency between an organized brute force and just a basic brute force. Yeah, that's nuts. And so I added all this up. So here you've got like the count. This is the number of passwords. Here's the percentage. So just using the brute force attacks, they got 98.13. You go down dictionary, you get less than a percent, less than a percent, less than a percent, less than a percent. But you add all this up, and it actually comes to 99.99% of the passwords they were able to get using these 17, I think, 17 different attacks. And that's nuts. That's insane. Some of these people had to have known like what they were doing. And granted, it is 1980s, so it's like the internet's not a big thing yet. You know, the security wasn't huge. People weren't freaking out about it. But still, that's nuts. So let's. Here's my resources. I will leave this up for a second, and then I'm going to go and check to see if it's finished. I'm sure it has. Yep. There you go. Yeah, so it took 1 minute 9 seconds. My computer sucks, and as you can see, it kept like popping up here that it is using a lot of my CPU. But so here, this is the hash that it guessed. Question mark, and then guessed one time. Took it 100% accuracy, and that's what it tried. It got it. Yeah, that's that was pretty much it. You know, it's just it depends. There's different types of hashing. You know, these different types of hashes. We used MD5. It checked it. Only to use it on a decent computer, not a pile of junk laptop that's running a bunch of stuff in the background. Probably, it should have gotten it in. You know, lickety split. But yeah, here we'll go back to resources. I'll leave these up for a second in case you want to see them. One more time, pause, so you know I'm not trying to plagiarize anything. But yeah, there you have it. Thanks for watching, guys.